Okay, so we're going to find a solution set for each of these inequalities and equations in Z and in R. So let's solve them first. In this, we're going to subtract 6 from both sides, equals 24. And then we're going to divide by 5 over 4, which is the same as multiplying by 4 over 5. So x is equal to 24 times by 4 over 5. Get rid of that. And that means that x is going to be equal to 96 over 5. And so we want to solve that in Z. Well, is 96 over 5 an integer? No. So in Z, we've got the empty set. Whereas in real numbers, 96 over 5 is a real number. So that is our solution set. It's a bit messy because it's a little bit small. Same thing with B then. Expand the brackets on the right hand side. And then we can see we end up with 5x plus 4 equals 5x plus 4. And in this case, we can see that all values of x work. So if we're solving this in integers, we know that all integers satisfy this equation. If we're solving this in real numbers, we know that all real numbers satisfy this equation. Question 2 then. So question C. I'm going to multiply both sides by 6. So I end up with 3x minus 9 minus 4x. 6 over 3 is 2. And then minus a minus, so we're going to get plus 2 is equal to 3 times 6, 18. Minus x, and then minus 7 is equal to 18. If we add 7 with both sides, we get 25 is equal to minus x. So x is equal to negative 25. If we solve this in Z, then is negative 25 a integer? It is. And is it a real number? Of course it is. In D then, we solve this inequality in the same way we solve an inequality with just one inequality sign. We can do operations to all 3 parts at the same time because we've only got a variable in one part of this inequality. So the first thing we'll do is going to multiply everything by 3. So negative 12 is less than 2x plus 1 is less than or equal to 3. Then subtract 1. And then divide by 2. And it's probably going to be handy if we write minus 13 over 2 as minus 6.5. Because when we solve this in Z, well, what integer solutions do we have? We have minus 6, minus 5, all the way up to 4. In real numbers, what do we have? We have the interval minus 6.5 up to and including 4. Question E then, we're going to add 2 to both sides, so minus x over 3 is less than or equal to minus 3. Multiply by 3, minus 9, and then divide by minus 1, x, positive 9, and we swap our sign around. So if we're solving in Z, we're going to have all the integers that are bigger or equal to 9. So 9, 10, 11, ... In real numbers, we're going to have the interval 9, including 9, up to infinity. 6f then. expand the bracket on the right hand side, group our x's, so I'm going to subtract 2x from both sides, I'm going to add 4 to both sides, and then we're going to divide both sides by 4. Now let's find a solution set in Z. Well, this is just going to be the set of integers that are less than or equal to 5. And in real numbers, we're going to have our interval, including 5, and all the way down to negative infinity. Question 7, we need to set up our own inequality then. The sum of 2 consecutive integers. Well, if one integer is n, the consecutive integer, the one after it, will be n plus 1. So there's the sum of 2 consecutive integers, and we know that that sum is less than 65. So find these numbers if their sum is a maximum. So we want the maximum value of n that satisfies this inequality. So let's solve the inequality. We know that 2n plus 1 is less than 65. 2n is less than 64. n is less than 32. And therefore the maximum value that n can take is 31. And therefore the number after 31 must be 32, and there are 2 consecutive integers.